Alright, today we're going to learn about exponential functions, and today we'd like to be able to evaluate exponentials, and we'd like to use the laws of exponents, and we'd like to be able to define the number e. And we'd like to be able to graph exponentials, and we'd like to be able to solve exponential equations. Alright, let's start with evaluating exponents, something like 2 to the 5th power. Now to do this, you could go 2 times 2 times 2 times 2 times 2, right, out by hand, or you could get out your trusty calculator, go 2, the caret symbol, raised to the 5th power. And either way, you'll get 32. That's all you need to do to evaluate these things. Okay? This is not hard, it's not rocket science, and the thing about it is if I had 2 raised to something like the 1.41 power, I'd go 2 raised to 1.41, and that equals something like 2.657, something like that. Okay. That's evaluating exponents. Not hard. Not evaluating exponential functions. You should all be able to do that by now, hopefully. Now, the next thing we want to look at are the laws of exponents. Hopefully you've seen these things before and you remember them. Something like if I have something base a to the x times base a to the y, when we multiply like bases, we add the exponents. Right. Now, if I had a to the x raised to the y, a power raised by a power, we multiply the exponents. Now, we could take that and look at it a little bit differently. If I had a times b in parentheses, and I had that all raised to the x power, that's the same as saying having a to the x, b to the x, right? I think of the exponents in here as 1, and I distribute the x onto both of them. Now, anything to the 0 power equals 1. Okay? Now we got a few more here to look at. And one of them is 1 raised to any power is equal 1. It's an identity. Now, a to the negative 1 is equal to 1 over a. When you have a negative exponent, you move the term to the other side of the division bar, and the exponent becomes positive. All right. Now, what else were we going to look at? Let's see. Those are the laws of exponents. We're going to use them in a little while when we solve some problems, but there they are. Just kind of keep them in your mind. If you're not sure of them or you don't remember them that well, get them written down, get them in your notes so that they're easily accessible. Oh, let's see. What were we going to do next? We were going to define the number e. The Euler's constant, sometimes it's called the natural exponential. You might have seen this in your biology or some of your science classes. This is a quantity that shows up in nature. And E is defined to be the limit as n approaches infinity. In other words, what's going to happen is we're going to let n get really big, and then we're going to put it into this formula, 1 plus 1 over n raised to the n power. Okay. Now, E is a number kind of like pi. It's a non-repeating, non-terminating decimal. So much like we would say pi is about 3.14, or people say pi equals 3.14, not really true, but people say that. We can say E is about 2.72. We're rounding to 2 decimal places, otherwise it's something like 2.718. So people consider E to be 2.72. Now, there is a button on your calculator that is for pi, and if you look, you will find an E button. You might find one that is e to the x, and you might find one that is just e. You might find both. Either one works if you need to use it. All right. Now, let's see. Let's take a look. Do we want to graph these things first or solve? Let's solve them. Okay. Let's say we had something like e to the negative x squared power, and that equaled e to the x squared times 1 over e to the third power. Okay. Now what we're going to use is we're going to use a fact that if a to the x equals a to the b, then x equals b. Okay. The bases are the same. If they're equal, the exponents better be the same. So now, what we're going to try and do is we've got e raised to something on the left side. We're going to try and make that right side become e raised to something. So we're going to use our law of exponents. We got e to the negative x squared. Now e to the x squared becomes e to the 2x times, well, this is 1 over e to the third power. If I bring that e to the third power to the numerator, my exponent becomes negative. Okay. So now I've got e to the negative x squared equals e to the 2x times e to the negative third power. Well, I can combine these two, and I get e to the negative x squared, and that equals e to the 2x minus 3. So now what that tells me is that negative x squared equals 2x minus 3, or 0 equals x squared plus 2x minus 3. And at that point we can factor. We get 0 equals x plus 3, x minus 1. So x equals 1, or x equals negative 3. How much more fun could it be? Well, let's see. Should we try another one? Should we find another good one to try? Should we think up a good one? How about something like eight to the 2x power equals 1/2 raised to the 4th power. Okay. Well, alright, that doesn't look at all like we're going to have like bases, but let's think a little bit. I can take this 1/2, I could move it, I could turn it into 2. I could think of that as 2 to the negative 1 power raised to the 4th power. because I know that 8 is 2 to the third power, and that's raised to the 2x power. So, let's see. 2 cubed to the 2x becomes 2 to the 6x power. 2 to the negative 1 power raised to the 4th power becomes 2 to the negative 4th power. That tells me that 6x equals negative 4, so x is equal to negative 2/3. Okay? Alright. So, now, let's see. Let's take a look at graphing one of these things. If I had y equals something 2 to the x, okay, and I was going to graph that. Well, first of all, I know that y is never going to be less than, nor will it ever equal 0, and I know that x is all real numbers. And I also know that when x equals 0, I know that y is going to equal 1, right? Because anything to the 0 power equals 1. And now when x gets negative, I could think of that as 1 over 2 to the x. So essentially I have a fraction, and I'm multiplying 1/2 by itself a bunch of times. So as I go towards the negative x-axis, the farther I go, the smaller my value is going to get. And the opposite is going to happen as I go towards the positive x-axis. It's going to get bigger and bigger and bigger and bigger and bigger. So, that's the general shape of an exponential. Now, all of our transformations really do apply to this. For example, if I had y equals negative 2 to the x power, well, it's going to look like that. Okay, it's going to be flipped over the x-axis. Now, likewise, if I had y equals 2x plus 2, I know that my graph is going to be shifted up 2. Right? In other words, 2 would become my new horizontal asymptote, and it would look just like that. And then, if I had y equals 2 to the x plus 4, I know that I would be shifted 1, 2, 3, 4 units to the left. So my graph would come and go like this. All right? So, there you go. We've evaluated, we've looked at the laws of exponents, we've defined the number e, we've graphed exponential functions, and we've solved some exponential equations. I won't be in class on Monday, so hopefully you can work on this and plan to come with questions on Tuesday. Thank you, have a good weekend, hope your Thanksgiving is nice, and if you're watching this before, I hope it is nice. Bye.